All right. We're moving into back-end development today. Congratulations. Welcome to the second half. Everything that exists as technology shares something in common. All technology that exists is an attempt to answer some kind of question. If you want to understand the technology that you're using, first you should know the question that it's attempting to answer. So the most of the problems that I find with students encountering backend development, databases in this next section is not understanding. And therefore, if you don't understand, it's kind of hard to care about what we're doing. And so it is with life. If you don't know the question, often the answer doesn't make a whole lot of sense unless you just say, well, it's magic, right? How does your phone work? It's magic. What's your phone there to do? It's to connect me with other people. And so sometimes if I know the question and I have a reasonable answer, the other parts of everything else that's going on doesn't quite, I don't have to fill in all the details. I have enough of a reason to continue forward using some sort of technology. So databases. Can anyone give me their best attempt at what a database means or what it does?
Place that stores data.
A place that stores data. Love it. Who here thinks that answer totally makes sense? Fair enough. But it has another question that's a part of it, right? What the crap is data? All right, everybody grab a piece of paper. All right, on that piece of paper, I need your name. I need your current age. I need the year you were born. Your mother's maiden name, your social security number. No, the names of your pets, if you have any pets. And I need any hobbies you have or a hobby that you have. So that's your name, your age, the year you were born, your pets' names, any hobbies you have. Give you like 30 seconds on this one. Hobbies can be like going to the gym, going for a walk, hiking, kayaking, acting like I'm in a kung fu movie, hobbies. Playing air guitar on stage in a real concert. Gesundheit.
Crap.
Been there. All right, real quick. Just wave your paper in front of the camera. We don't actually have to see what you wrote. All right. What is on that paper?
Data.
Data. What is it? What's the data?
Data is defined by what you wanted us to put on it.
Okay, data is defined by what I, Austin, desire. I like this idea. What is this data?
Information.
Information in what context?
About ourselves.
Okay. Is there a literal specific relationship between that data and you?
Yep.
Yes.
Seems that way. But
Well,
there are other Austin Walkers who are 31 and were born in San Diego and grew up in San Diego. One of them is a teacher at Cathedral Catholic High and is a lady who's also a redhead. Yeah, same age, born a month before me, by the way. 1 month to the day.
That's probably what you do on your weekend.
Yeah, there you go. I'm in Texas. But that said, like that data is not inherently specific to you. What's it specific to?
The paper we wrote it.
Piece of paper, yeah.
Itself. Correct. That's it. It is one set of data that's only specific to itself. Without one of those pieces, it's incomplete. With all those pieces, it is complete. It's what we might call a set of key value pairs. What do we call that?
Objects.
Object.
It's an object. It represents a real world object, but it could represent many different kinds of real world objects. Very weird, huh? Okay, so here's the issue. How do we take that data right there that's temporary and specific and hang on to it long term?
Store it,
In a
Where?
database.
database, from a
But that's a piece of paper. Where am I going to store that?
In a notebook or a folder.
folder.
Okay, how long will that last?
Until we throw the folder out.
What's the longest storage that we have of data?
Memory?
Your memory.
Nah, that only but lasts about 80 years.
Rosetta Stone.
That's pretty old. It's not the oldest.
Actually, that's the one on Voyager.
That's pretty good. There are tablets from not Mesopotamia. There's the Indus Valley Civilization. There are tablets marking people who were late to work and why they were late to work. And that is the oldest form of information we have stored as humans. And it was carved into clay tablet and fired and maintained. One person was late to work because they were brewing beer. And that's just why they were late to work.
Solid.
The other oldest one is a list of complaints from China from from a company selling them something. It's like 5,000 years old. Amazing. Like, humans have been storing data for a long time. Those were stored in collections of data we called libraries. And so these are actually in some clay pots, but they were lists of data that were stored inside of a container. As developers, you all got it already. That container that we are utilizing, we're going to call that a database. So we are going to take containers and we're going to set up containers so that it can store data. And then we're going to learn how to access the data in that container. So today we're learning just how to access data inside of the container. The container is already set up for us. Our container is called Postgres. The language that we're going to be using is called SQL, SQL, or no, not SQL, SQL or SQL, whichever one you want to call it. That's what we're going to be getting into. But the important part is understanding what's going on with databases. Okay, with that, we're actually kind of short on time. So I'm going to start sharing my screen and let's start writing. Any questions as I write things out? Okay, one word, Austin. Today is the 30th, 2022. All right, something we have learned already, and we spent a little bit of time on, and we let our brains melt a little bit, is something called classes. Can anyone give me a quick description of what a class is?
Blueprint of an object.
Of one object?
Of objects in that class.
How many cookies can a chocolate chip recipe make?
As many as you
As
want.
many as
When
you
have the
want.
ingredients.
Yeah, a lot.
Blueprint for as many objects as we need. All right, let's build out a real quick class together. Let's do. We'll do this in Ruby. Class learn student. Def initialize. What did we say? We said name, age, DOB, date of birth, pets, and hobbies. Make some shadows real quick. Let's do pets last, actually, because we'll set pets to a default of empty array in case you don't have any pets. All right, it's getting a little confused here, but we'll be okay. All right, we got a basic learn student class, right? This class, how many learn students does it describe?
None right now.
How many could it describe?
As many as you.
Many as you want.
Could describe all 600 plus learn students we've ever had. Pretty cool stuff. All right, let's come up with a quick learn student. I'm trying to find who I haven't called on today. Rashad, I want to learn a little bit about you.
Okie dokie.
You know what? Actually, I'm going to bring this down a little bit. Bring that up. Rashad, if I remember correctly, you said you were 39.
Yes.
Cool. If you want to give us your real date of birth, you can. If you want to give us a fake date of birth, you're also welcome to.
If I give real date of birth, do I get birthday presents?
I think we are obliged to give you some sort of birthday acknowledgement and present if you give us your real date of birth.
No, it's June 22nd, 83.
So we'll come up with some sort of like code for that real quick. Maybe we'll throw that in a string actually. Do you have any hobbies?
I ride motorcycles, Harleys.
Motorcycle / flirting with death. California's scary, man. Motorcycles.
Yeah, it is. That's for sure.
Out here, it's a little bit nicer because it's again Texas, so like there's lots of open, nobody lives there places.
Mhm. Yeah, I rode through Texas a few times.
All right, and then any pets?
Yeah. My wife has a cat. I call it cat, but she calls it yen, so
We'll go with cat. I like cat. All right, so Rashad is a learn student. And if we were to run this code, what would we get? What kind of data would we get? You know what? I think I really can run this code actually.
String and array.
A hash.
Yeah. Formal argument cannot be an instance variable. Lame. Oh, age equals age doesn't work. What is going on there? Huh.
Is it because of the comma after pets?
Oh, it is exactly because of the comma after pets. Then maybe that would have worked in IRB. I should not have neglected that. I want to see if that works now. Where did it? Yes, I did mean HP. So it totally would work. That's fun. All right, we got a hash. Sorry for moving around so quickly, everybody. And this hash is specific in that it's a unique set of data, but it has information about Rashad that's unique to Rashad, hopefully, or mostly unique to Rashad. All right, this is data. And this is the sort of thing that we are looking to save long term. And so when we come up with a class, we can use these classes to create structures inside of our database. And those structures are called models. So what we do with our data that our classes makes and how we store this information, this is where databases come in. And a database will store information according to these classes by utilizing something called a model. Okay, in real life, what is a model? Not the people, not the job.
A scale down,
For back to.
whatever you're looking at.
Okay, a scaled down representation of whatever we're talking about. Scaled. Anything else? Can anyone does anybody have any models in their home? Cody's got a model.
I build like the Gundam things.
Gundam model.
I got a lot of Legos.
Hobby Lobby.
Legos. Anyone else? What's a model that you visited maybe with your parents or on your own terms that is full scale?
Statue of Liberty.
Okay, I was thinking something like a model home. What's a model home do?
Aren't you able to like move it? Like easily movable, or I think it's something different.
Maybe
Um,
this is just like
An example for you to walk through if you were gonna buy a track home in a suburb of every house looks the exact same area.
or
like
they
text-
all look exactly different. Think Nuketown from Call of Duty, for those of you who remember. So models have some meaning in our real life of like they're representatives of what something could be, right? I could have a real size Gundam. I could have a real like big blocks that Legos I can make a thing this with. Minecraft is like a whole model world. Roblox is like a whole model world. You could have stuffed animals or models of real animals, that kind of stuff. A model home is full size, but it's an example of it's a representation of the thing that you can walk through. So we can say it's a simplified representation of something else. Another way to put it, it's similar to a class in that it describes the structure of the thing it represents. Anybody ever see the Millennium Falcon model by Lego, or just like the build out Millennium Falcons? Like it's describing some potential structure that might ever exist. And so in databases that are SQL databases use models to describe the potential structure of the data that you're going to store inside of our database. This structure will almost exactly correlate to the data and behavior of classes. So if my classes have this data of age, date of birth, motorcycles, Rashad, cat, then my database can hold these things: age, date of birth, hobbies, pet names, and pets. And that's what that structure is going to be, is that's what it can hold. So that's a model. The way models hold individual pieces of data is called instances. Anyone talk to me about what an instance is in computer programming? Cough, cough, Holden.
It is a brand new copy of something that you had blueprinted earlier via a class. Or, yeah, object. Whatever.
Cool. Each instance is an entry into the database. So a database can hold lots of entries, and you create an instance in that database. A good example of a database that has instances, who here has their friends all getting married and it's super annoying? Okay, only like a few of you. One day, your friends will all start getting married and it gets super annoying because you have to go to a bunch of weddings. Those are fun, but like you also have to get a bunch of presents. That's annoying. But when you show up, there's a registry and there's a bunch of things that says like your names and like, did you bring a gift, and like and you have to fill that out. And every time somebody fills out one of those lines, that's an instance in this data collection of this database, which is this. Oh, it's not a registry. It's like an attendance book. I don't know what those are called. Somebody correct me here. But every time we fill out a line, that's a new entry. That entry is an instance in the database. And it follows the same format of data. Okay, every single instance must follow the structure of the model/class that it is based on. I'm going to start using the terms model and class really close together. They are a Venn diagram that's like this. They are overlap in lots and lots of ways, but some ways they are a little bit different. They are their own things that just overlap a bunch. So I'm going to use these terms close together when I'm talking about models and classes and the way that we're interacting with that data. Because to make the data, I have to interact with some code. That's the class. To save the data, I have to interact with the model. That's on the database. And that class and that model have to match up in order for me to take that data from the class to the model, even if I have some sort of translator. Let's see who's remembering. What's a translator between two incompatible languages? What's that called when it comes to object-oriented programming?
ORM.
An ORM, object relational mapping. It knows how objects look here. It knows how objects look here. It says, I can transform this into this. So that's what's going on. All right, each instance has a special unique identifier called a primary key. The primary key is something that is going to be unique to every single entry in the database, and it will never be copied to another entry in the database. So we have in this class 21 students plus 2 instructors. We need primary keys that are unique to every individual in this class. What would be something that would be useful for primary keys in our class?
I guess our first and last names. Well, in this class, it would work.
Okay.
Our socials.
Okay. Why is your social going to be a unique identifier?
Because nobody else has that number.
You
It's
hope.
only given to people who are alive. Ideally.
You hope. What's another unique thing that we could have?
A username.
Prince,
Usernames aren't unique across all platforms.
Password.
Student number.
What PIN number?
And student number.
Okay. So we got 2 numbers down. All right, so y'all are in the 600s. What would be your unique student number if you're just to guess? Obviously, we can't actually know.
We could do like E6 something.
Oh, so like okay, license plate. That's fun.
Yeah, because we're Echo cohort. So E6 something.
Okay. What if we just started counting?
I mean,
What
yeah,
if I just started at Elijah and I just said Elijah's number 1, and I said Joyce is number 2, Holden's number 3, Sam's number 4, Joseph's number 5, DeWeed's number 6, so on and so forth. Would those be unique identifiers?
yeah.
In modern SQL, primary keys are integers. Primary keys are given to data entries without your input. You are not in control of primary keys. You're not in control of changing them. You're not in control of giving them to the database. Why is this a good idea? Make a guess real quick.
So there's no duplicate.
There's no duplicates or no funny business. What if your database is handling a bunch of money? Right? Someone goes in there's like, this didn't happen here. This happened over here. That's not good. You do not want to be messing around with primary keys. So one of the things you're gonna have to run into is you're gonna have to run into how to use the fact that your primary keys are given to your entries of data without your consent. / they're just part of the database structure itself. So we have a class here. So if we're thinking about this object gets mapped into our SQL database, then what happens? What does this object become?
A model.
Okay, a model. And we have 1, 2, 3, 4, 5 key value pairs. When it goes into our database, how many key value pairs does it have?
Should have those 5, right?
6.
It'll get a 6th prime key value pair, which is called primary key. Sometimes it's called ID. Okay. Holy crap, that's so much we just covered in such a short amount of time. 5-minute break. All right, when we come back, we're gonna start coding in this stuff. Real quick, things I have missed in this last 20-minute blaze through of databases. We did not talk about schemas. We will get into those with Rails. We did not talk about tables. We talked about rows. These are individual entries in a database. Columns are the different kinds of data. We didn't talk about relational databases as compared to other kinds of databases, but these are essentially what you think of when you think of an Excel spreadsheet. You can have like items on top and then numbers on the left-hand side, and every single thing goes inside of it. We didn't talk about database tables as being each table represents its own model, and each model is a class. These are kind of interchangeable with the three of them when we're talking, so we can say table, model, or class. That's confusing. These things we don't have a way to represent right now in what we're dealing with. We will look at a table here in just 1 second and some columns. But schema, we don't have a way to look at until we hit Rails. Please just familiarize yourself with these terms, add them to your flashcard set. We're going to be using them a lot. If they don't make any sense to you, or if you don't just have a definition to work off of, then they're just going to kind of go in one ear and not the other. Trust me, I know I did that. Cool. All right, that's the part I glossed over in the intro to database section. We are going to be moving on to the PostgreSQL queries. The tricky part of this challenge section this afternoon is actually getting set up on PGAdmin. PGAdmin is a application that's installed on all of your MacBook Airs that we will be utilizing today to run database queries. Everyone's going to need to do a little bit of setup. That's where you are going to be creating a server. The server has to have a special name called localhost. We'll probably do this together this afternoon after once we get started with challenges, and then we'll have to do like some password inputs and that kind of stuff. So if you change your password from SD-learn123 for your computer, you'll need that password later this afternoon. With that said, you probably won't be able to follow along with me like doing this yourself. So I recommend just chilling with me for this next section, taking some notes and looking at the syllabus as we move through these database queries. SQL, also SQL, it stands for Structured Query Language. Structured Query Language. And we're going to be using a special flavor of SQL called PostgreSQL. PostgreSQL, or Postgres plus SQL, is a language that is a combination of two things. It's a combination of the structured query language plus its own database engine. And PostgreSQL requires a special program running on your computer to be utilized, or on the server that it's hosting to be utilized. We have that installed on your computers already. There is a chance actually it's failed since you got your computer, and now we'll just have to restart it or reinstall it. So that's just a thing to know about. Sometimes it's abbreviated as PSQL, just a heads up. PostgreSQL is strongly OOP. Can anyone tell me what OOP stands for? Somebody who hasn't spoken up today.
Object-oriented programming.
And SQL is used by probably some of y'all's favorite sites. Reddit uses SQL to store all of their users, posts, comments, everything they do, data sales that they make, all that kind of stuff. They use structured query language to create that data, update that data, read that data, and delete that data as they need. Another platform that uses structured query language is Instagram, and therefore Meta. Spotify is a favorite, as well as the ISS. The International Space Station, if you believe in such a thing. I'm joking. But I got a few of you. So, structured query language is everywhere. It's a very sought after knowledge, and it is a very deep knowledge in what can be done. But in fact, it's very simple, and we're going to learn it here in the next 30 minutes. So let's get to it. A query is a request for data, or it's a request for an action related to data. All right. I have asked you to memorize something today. Who can tell me what that thing was?
Craig.
CRUD. A request for data. What part of CRUD do you think this would be associated with?
Create.
Read. Read.
And request for actions related to data. Who can give me or related to the database? Who can give me what this might be in CRUD? These are the only two options, by the way.
Update.
I got my C, got my R, got my U.
Delete.
All right, so queries can do these four things essentially. They can read the data that's in the database, they can update the data that's in the database, they can create data in the database, and they can delete data in the database. Queries have their own language, and with their own language comes their own specific keywords. The first and most basic keyword is select. And the select keyword has a partner, which is from. Select this data from this table model class. I want this data from this place. Select from is the most basic query. It likes pumpkin spice lattes, sweaters on a cold fall day, and it appreciates it when its friends reach out to them every single day. No? No one likes my basic joke?
Too much contact with other humans.
Got it. Do basic people like being contacted every day or not being contacted every day? Is there somewhere in between?
I think they like to. I don't.
All right. Acidic would be Cody then.
Oh God.
For all my Kim fans out there. Select is going to tell us what data sets we're calling upon. Also known as column headers. Again, this is one of those things I'm gonna have to show you before we get into it. And from tells us which table or model or class that we want to see that data from. Okay, I'm about to hop into these actual queries, y'all, and something I'm going to acknowledge right now. I'm giving you zero context for how I got here or what's happening. I'm also trying to wrap this up in 30 minutes. Cool? Context will come later. Is that cool? Cool. Please don't be broken. Please don't be broken. I did check it earlier this morning. It was working fine. Yes. I'm using version 420 because it's the best version. No, it's not. I think you guys should all have the latest version of like 6.09 or something like that. All right. Uh-oh. That was here. All right, give me a sec. Object create server, don't have server. There it is. Postgres to user. All right, so we are doing this together. When you open this up, you're going to be looking at servers, local, or in servers, you do right click, create, and then server. It should have been an object. It might actually be an object for all of you. But we are going to create a new server. Inside of connection, we're saying localhost or 127.0.0.1, which is a redirect. The username is going to be Learn Academy, and then the password is going to be SDLearn123 for all of you. With the passwords, I'm resetting it to my personal password right now. We'll save that password. And then name must be specified. We'll call it countries. Save. Oh, never mind. That was should have been. Cool. Remove that. Name localhost, connection, localhost, Learn Academy, and then your personal password. Learn ACA. ACA does exist. Cool. Servers, localhost databases. And then there should have been a histories. Or a countries, which I don't have countries. And I thought I just had this a second ago. Well, looks like I wasn't ready for that one. Anybody else have the countries file floating on their desktop right now? Catherine, can you drop that in Slack? And then I want to download this. Cool. Can I do a drag and drop here? Okay. One second. All right, my bad. In case you don't want it, there's a hot mic out there. All right, let's just do a quick search. It should just be a quick query like the one we're trying to do, and this query does exist. Let's do pgadmin. Okay, after clicking restore. Schemas refresh. All right, I see two ways around this. I need help, and the person who can help me the most isn't available right now, isn't available because they're in a meeting. So I think we can do an early lunch, come back at 12:30, get started. Does that sound good? That gives you guys a break and I don't have to flounder in front of you for 30 minutes. Or do you guys want to do an early lunch? We come back at 12:45 and we just burn through this together. What's going on at 1 p.m.?
12:45.
All right, let's come back at 12:45. We'll go through queries, we'll play a game of Kahoot, and we'll hop into challenges. See you at 12:45.